Hey, what's up, Chem peeps? Who is ready for a thriller of a free response? You know it's going to be exciting anytime stoichiometry is involved. In order to generate hydrogen gas for a combustion reaction, a student reacts a 2.00 gram piece of magnesium metal with a concentrated hydrochloric acid solution. After 20 minutes, no solid magnesium remains. Part A. Write a balanced chemical equation that describes the reaction of magnesium with hydrochloric acid. Easy. Magnesium reacts with hydrochloric acid to form, maybe not so easy. What are my products gonna be? Well, read your question carefully. This reaction is used to generate hydrogen gas. So we're making hydrogen gas, and then think to yourself, element by itself, compound. We kick out one of those things in the compound so that it's by itself. Single replacement reactions. Magnesium slipping in there to form a compound with chlorine. Again, be cautious. Think about your nomenclature first before you try and balance this. That nomenclature is so important, and you want to be comfortable writing the formulas before you try and balance. Alright, solid on the formulas. Let's come up with coefficients to balance this thing. Oh, so easy. Just a coefficient of 2 and we're done. Balanced. Subpart I. Which reactant was the limiting reactant? Justify your response. Alright, well, I've got 2.00 grams of magnesium. I'm not given any amount of hydrochloric acid. How am I supposed to determine what the limiting reactant is if you don't tell me how much of each reactant I have? Way to mess this up, Boylan. No, sometimes I'm just asking you to think about, do you understand in a general sense what a limiting reactant is? As you read this question, we're told that after 20 minutes, no solid magnesium remains. Well, what does that imply then about which reactant is limiting? If no magnesium remains, that means it's completely used up and must be the thing that's limiting the reaction. If, after the reaction is completed, there's still some magnesium sitting there, it tells me that it's the HCl that's limiting. Loving it. The limiting reactant is magnesium. A limiting reactant is one that is completely consumed in a reaction. This is evidenced by the fact that no magnesium remains after the reaction is complete. Again, if after the reaction was complete, there was a big old chunk of magnesium, well, we would know that it's the HCl that was limiting. Moving right along to part B. Calculate the theoretical number of moles of hydrochloric acid that reacted. You must show a numerical setup using dimensional analysis. Dimensional analysis to receive credit. Alright, we want to start with the limiting reactant, and we've already determined earlier on that it's magnesium. And we're starting with a whopping 2 grams of magnesium. Boom. First thing I'm going to do, convert that amount in grams to moles. How am I going to know what the mass of 1 mole of magnesium is? I'm going to turn to my trusty periodic table. Boom. Next, let's compare moles of magnesium to moles of HCl. This relationship comes from our balanced chemical equation. Quick peek back up at the reaction that we wrote in part A. The relationship is a 1-to-2 relationship. 1-to-2 relationship. Calculator time. 2.00 times 1 divided by 24.30. Let's take it one step at a time. My 2 grams of magnesium is really 0.08 moles of magnesium. And according to my balanced chemical equation, however many moles of magnesium I reacted, I must have reacted twice that number of moles of hydrochloric acid. Times 2 divided by 1. To 3 sig figs, I've got 0.165 moles of HCl. Boom. Moving right along. The student ignites all of the hydrogen gas generated by combusting it with excess oxygen to form water vapor according to the unbalanced chemical equation below. Part C. Balance the equation by placing the appropriate coefficients in the spaces above. How easy. I'm going to place a coefficient of 2 with water to balance my oxygen, and then a coefficient of 2 with hydrogen to balance out my hydrogen. That brings us finally to part D. Calculate the theoretical number of moles of water vapor that was produced. You must show a numerical setup using dimensional analysis. dimensional analysis to receive credit. All right, now let's go back up to the very beginning and think about our 2.00 grams of magnesium. First thing I'm going to do, convert this to moles. Again, we're going to use our trusty periodic table to determine the mass in 1 mole of magnesium. Next, let's compare moles of magnesium to moles of hydrogen. In our balanced chemical equation that we wrote in part A, that relationship is 1 to 1. 1 to 1. So if I stopped right here, I would determine how many moles of hydrogen that I created, that I generated in that first reaction. Next, if all of that hydrogen was reacted according to the equation here, the second equation, the relationship between moles of hydrogen and moles of water is 2 to 2. And then finally, to get back to grams, I'm going to use my trusty periodic table to determine the mass in grams of 1 mole of water. Calculator time. 2.00 times 1 answer divided by 24.30 answer times 1 answer divided by 1 answer times 2 answer divided by 2 answer times 18.016 answer. So my mass of water produced 1.48 grams. Boom, we are done.